saved it. I just forgot to post it. So, today, talking about multiplying and dividing radical expressions. To multiply, we have a property, fairly straightforward. Sorry if you can't see it. I don't know why I can't make these darker, but it says the nth root of a and the nth root of b. And over here it says the nth root of a times the nth root of b equals the nth root of ab. All the examples were very light and hard to read also, but I just blew them up big so they were better. Try it again. So this means that the cube root of negative 3 times positive 9 could be rewritten this way. As negative 3 times 9. Okay? Now, these numbers are not difficult for you. I'm sure most of you, if not all of you, will look at this and say, 9 and 3 is 27. Cube root of 27 is 3. But some of you, maybe you don't see that. And when the numbers are much bigger, they're harder to see. So, my suggestion is, instead of making this 9 and 3 into 27, look at it as a negative 1 times 3 squared. Now, I know I'm going slow here. I'm going to take a lot of steps. And you might ask me later. You don't have to ask me because I'm going to say it now. You don't have to do everything I'm showing you. Okay? I'm trying to show you techniques for those who are confused on what's happening, for you to sort it out. If you totally get it, then don't worry. You don't have to show all this stuff. What is 3 times 3 squared? Do you agree it's 3 cubed? Yes? Okay? And I'll go this way now. And so, cube root of negative 1 times the cube root of 3 cubed. And the cube root of negative 1 is negative 1. And the cube root of 3 cubed is 3. Remember, those were the rules we talked about yesterday. So my answer is negative 3. No way do I expect you'll show all those little steps. No way do I expect that. I only show it to you the first time so that you realize I don't have to make it into one big number that I don't get. I can break it down into smaller numbers that I do know and understand. Okay? So when I look at this one, 8 is really 2 to the what? Two to the fourth power. No, but nice try. It's really 2 to the 2 times 2 times 2, right? 2 times 2 is 4, times 2 is 8. Do you agree? So it's really 2 to the third times negative 2, which is a negative 1 times, oops, sorry, fourth root. Sorry. Fourth root of negative 1 times 2 to the fourth. Well, now we have a problem, don't we? Can I take the fourth root of a negative number?
No.
No, I can't. So the question, if it's asking for all the real roots, we would say none. They can't simplify that. Okay? If they're asking for, imaginary, if they're including imaginary, then I could say this reduces to 2i. Okay? But I think in these questions, they're just asking for real roots, because it says simplify if possible. Multiply and simplify as possible. So if I just go ahead and multiply, I get the fourth root of negative 16. but that doesn't simplify. I can't take the fourth root of a negative number.
Mr. Mitchell?
Yeah?
If you can look at it and tell that it doesn't simplify, do you still have to show the word and then put none?
No.
Alright.
No, you're big boys and girls, and I'm always showing you every step to make sure I don't lose anybody.
Alright.
Eventually, you're going to have to demonstrate on the test that you can actually do it. So, that's where most of your points are anyway, right?
Yeah.
Okay. 54. Does 2 go into 54? How many times? 27. Does 2 go into 27?
No.
No. Does 3 go into 27?
Yes.
Yeah. 9 times? Does 3 go into 9?
Yeah.
3 times. So what I just did is I took 54 and I broke it down into the prime factors. So 54 is equal to 3 cubed times 2. Do you agree with that?
Yeah.
Okay. The reason I did that is because I'm looking for the cube root of 54 up here. And so I can break this down into the cube root of 3 cubed times 2, and then n to the 8th. N to the 8th. How many n's are there in n to the 8th?
8.
8. And I need to break them up into groups of 3. So that gives me n cubed times n cubed. How many is that? 6 times n to the what? To the second. Because I need how many altogether? 8. And now, if I break it down like this, it's easier. What's the cube root of 3 cubed?
3.
3. What's the cube root of, well, we'll just do this, n cubed?
And
N. And the cube root of n cubed is n. And then nothing else has a cube in it anymore, does it? So I keep the 2 and I keep the n squared in there. If you're asking if I can rewrite this as n squared, that's exactly what we'll do. So we end up with 3, and n times n is n squared times the cube root of 2n squared. So this is simplest form. Makai, I couldn't hear you. Is that what you're asking? Okay. Yeah.
how is that simplified, but number 2 isn't? Because they're still square rootable. Number 2 you
Number 2, we couldn't simplify because they're imaginary.
Oh.
Number 3 wasn't simplified because altogether I had 3 factors of negative 3, or 3 factors of 3 and 3 factors of negative 1, however you want to look at it. Okay? So I can break it down. So to be in simplest form, I don't want any powers left inside that could be reduced and brought outside of the radical sign. Does that make sense?
Yeah.
Okay. So when I look at this, how many 5s are in there?
2, 5.
Yeah, you're right. There's 5, but you were right in what I was really asking is, how many products of 5 are there in there? And it's 5 times 5, so there's 2 factors, 2 powers of 5. That's what I was trying to ask. I didn't ask it very well. So when I simply asked how many 5s are in 25, you're right, there's 5 of them. It's 5 times 5, so that's a power of 2. So if I put these together, combine them, I have 1 power of 5 there and 2 powers of 5 here gives me 5 to the 3rd power. Do you agree with that?
Yeah.
And then I have 1 power of x here and 4 there, that's how many?
5.
5. But I want groups of 3. So would it be okay to call this x cubed times x squared?
Yeah.
Let me erase.
How'd you get 5x's out of 1?
I didn't. I got 5 x's out of 1 and 4. I had 1 here and 4 there.
I see.
Okay? Now, how can I break my y's up? 9
9 and 2.
and 2.
Yeah.
Okay?
Oh, 3, 3, 3, 2.
3 and 2, you said?
Yeah.
Yeah. You know, if you want to go this way, you can. You said I had 3 of the 3's, right?
Yeah.
So I can do that. And then there's 8 and 3, that adds up to 11. And this is how many? 9. So I need 2 more, don't I? Okay. So let's simplify. 5 cubed root of 5 cubed is 5. Cubed root of x cubed is x. X squared doesn't simplify. And the cubed root of y cubed cubed is
5 cubed.
y cubed. Leaving me with the cubed root of what was left. This one
X squared and y squared.
and this one. Okay? Now, these are all odd roots, aren't they? These two that are shown here. This one didn't work. It was an even root, and that's an odd root. The reason I asked that, remember we started talking yesterday, if we had an even root and it simplified to an odd power, we had to put what in? Absolute values. Okay? I'm sorry. Is that better? I didn't mention it for 2 reasons. I always think of that after the fact. But I was safe here because it didn't apply to any of them that we've done so far. But maybe in the next set of 4, it'll apply a little more. Okay? Any questions on how we left our answers? Okay, anybody not finished writing these down? Okay, the next rule then is for division, dividing radical expressions. Pause that while you copy that down. Let me read it first in case they can't see it at home. It's nth root of a, nth root of b, not equal to nth root of a over the nth root of b, and this says the nth root of a over b. I do want to make sure that I say to you, I probably never do a problem the same way twice. These kinds of problems, when we're simplifying, sometimes I'll do it one way, sometimes I'll do it another way, sometimes I'll do it a third way, sometimes I'll do it for one student one way and do it for another student another way. There is no one right way to answer these. Sometimes I apply the rules one direction, sometimes I apply the rules another direction. As you saw earlier, sometimes I go one direction to get them together, and then I go another direction to separate them to simplify it. Okay? You just have to realize what the rule says, and then use them back and forth, whichever is easiest for you. Okay? When I look at this one, because when I look at 81, I know that's 3 to the 4th. I'm going to want to put them together and divide. That's the first thing I'm going to want to do. I'm going to write it as the cube root of negative 81 over 3. And what's 81 divide 3? Well, let me ask you this. What's 3 to the 4th divide 3 to the 1st? 3 to the 3rd. And 3 to the 3rd is 27. And so I get negative 27. Again, it's an odd root, so it's okay to have a negative. What times itself 3 times gives me negative 27? Negative 3. Okay. What's that?
It was really fast how you said it. Right over my head.
Okay. So don't say nothing. Say, can you slow that down and say it
no,
again?
it's okay. I understand it.
You do understand?
Yeah, I got the right answer.
Okay. Anybody, did I lose anybody else? Sorry. I will try to slow it down for you.
Mr. Mitchell, you're on record right now. Don't forget that.
Mr.
Cut that part
Mitchell.
out.
All right. Just recorded my sarcastic sense of humor. Here we go. So the next one. What do you think? Should we put this together or no?
I think we should get rid of that X in there, Bob.
Ah, so you agree that there's some factors up here that maybe will reduce with these.
Yeah.
So whenever you think that way, you should write them as 1. 192 over x to the 8. I'm sorry, 192 x to the 8th over 3x. And you're right, x will go into there, leaving me with how many x's?
X to the 7.
X to the 7. Does 3 go into 192? Who said what?
It does.
Why would you subtract it from?
Get rid of the X at
Because
the bottom.
that's the rule, remember from Algebra 1, when you're dividing common factors, you subtract the exponents. So if I'm dividing x to the 8 divide x, that becomes x to the 8 minus 1. Okay, because this exponent, that exponent was a 1, right? Okay.
It's 64.
3 goes in there 64 times.
Yeah.
Okay. Does anybody look at 64 and know what it is? 4 to the
Third.
third power. That's right.
Yeah.
Now, if I didn't know, okay, a little sidetrack, then I'll erase it and come back to it. If I did not know what 64 was, I would do my division again. I would say 2 goes into there 32 times. 2 goes into there 16 times. Use a calculator if you need to. 2 goes in there 8 times. 2 goes in there 4 times. 2 goes into there twice. So 64 is 2 to the 6th power. Well, if we broke that up, that would be 2 squared to the 3rd power, which is 4 cubed. That's how we get 4 times 4 times 4 is 64. Okay? Anybody still writing that down? Anybody not want me to erase this yet? Okay. Some people, some teachers in fact, teach prime factorization. That's what we're doing. We're finding the prime factorization. Some teachers teach that with trees. And they branch it off. And they say things like this. Whoops there. 64 is 2 times 32. 32 is 2 times 16. 16 is 2 times 8. And when they're done, they get all these 2's. Okay? So you may have seen it done that way before. I don't teach that because sometimes your factors are all over the place. And this way, they're always right there. That's the way I teach it this way. Okay? Anybody not done copying down that example yet? All right. Now let's go back. So, you told me the cube root of 64 is 4. So we could bring that out right away if we want to. And then let's break my x to the 7th down. Yeah, x to the 3rd times x to the 3rd times x gives me 7 of them, right? And so I'm going to get 4, and how many x's out here? 1 here and 1 here is x to the second, leaving me with a cube root of x. What's that?
Hey, how is x in the second again?
Um,
That's the number 2, right?
yeah, still number 2.
Oh, no, I get it now.
I don't get it.
That's all right. I'm gonna just trying to move this up a little bit.
Oh, I get it now.
So for this, I left out this step. Hey, please stop. I left out this step that says the cube root of x to the cubed is x, and then the cube root of x to the cubed is x, and then the cube root of x, I can't do anything with it. So we leave that in here. So these two factors of x became x squared. Okay? All right. Now, I'm going to erase all this. Can I erase it now? And then I'm going to move that up there, just so we still have the answer up there. And we still have room to work. Okay? So now, something we haven't covered and something that's not in that property I gave you is this next problem. Okay? To answer this, to simplify this, first of all, are there any common factors between 3 and 5? No. Are either of them perfect squares? No. So what we have to do to simplify this is called rationalizing the denominator. Rationalizing the denominator, that's what we have to do. You've done this in Algebra 1, and you did this again last year in geometry. If you're taking geometry now, you haven't done it yet. But you will. And hopefully when we do that in geometry, you'll remember us doing it here. So if I rewrite this square root of 3 over square root of 5. Why this rule exists, I don't know. I'm the messenger. Don't blame the messenger. Okay? I didn't create this rule. I don't know why they think it's simpler to write it without that square root in the denominator. And I don't know why, because to be honest, I don't care why. I really don't. If you care why, then you can get on Google and research why did the mathematicians at one time say we don't want square roots in the denominator. I don't know. But to be honest, I've never been the kind of person that really cared about why a rule exists. I hear the rule, I understand the rule, I use the rule. Okay? So, the rule is I can't leave a square root sign, a cube root sign, a fifth root sign, or any other radical sign in the denominator. So we have to rationalize it out. And the way we do that is we multiply by whatever it takes to eliminate that. And I'm going to multiply on the top and the bottom by the same number, because what's 5 over 5 equal to? 1. What's square root of 7 over square root of 7 equal to? What's square root of 1,000 over square root of 1,000 equal to? 1. Now let me change avenues. What's 7 times 1? 7. What's 18 times 1? What's negative 1 billion times 1? So when I multiply by 1, I'm not changing the value, am I? So by rationalizing and multiplying by the same number over the same number, I'm multiplying by 1. I might change the way it looks, but I'm not changing its value. Right? So when we rationalize, whatever we multiply by the top, we have to multiply by the bottom also to make sure it's still equal to what it started as. Okay? And so what would I multiply by the square root of 5 to make it no longer a square root?
5.
Square root of 5. Yeah. And since I already had that square root sign, that's probably what you're realizing. Okay? And so I put the same on the top. And so on top, square root of 3 times square root of 5 is square root of 15. And on the bottom, square root of 5 times square root of 5 is 5. And for some reason, Your brain sees square root of 15 over 5, and it's going to want to reduce. Okay? But it doesn't. Square root of 15, that's the square root of 3 times 5. That's not the same as 5. Okay? So I'm just going to write a little note here, and then I'll erase it so we have room to do the next one. Never cancel factors in the radical with factors outside the radical. Okay? You cannot cancel factors inside the radical with factors outside the radical. Because if you do that, you're saying square root of 5 and 5 are the same number. Okay? Thomas, do you think square root of 5 and 5 look like the same number? No. No? Good. Because if you think that square root of 5 and 5 are the same number, and you think it's okay to cancel them like that, then I would love to give you today square root of $5, as long as tomorrow you give me back $5.
Okay.
Good deal?
No.
It works for me. So I'll give you a little more than $2 today, and tomorrow you'll return me $5, and we'll call it even. Okay. So never cancel factors inside a radical with factors outside, because they're not the same number. They're not really the same factor. Can I erase this now? Yeah, I'll just move this over here. There's our answer. Okay, now, when we look at this one, we probably, before we get into rationalizing, I don't usually recommend you rationalize instantly, because a lot of times if you do that on a problem like this, you're going to end up having to simplify later, and sometimes you have to re-rationalize again because you didn't really eliminate what you thought you were going to. Okay? So my first suggestion would be to write this in both square roots. So write it as x to the 5th over 3x squared y. And what happens to my y or my x squared? It cancels with how many of those? 2 of them, leaving me with 3 of them. So I end up with x cubed over 3y. Okay? X cubed over 3y. Now what I would do is break it back up. Okay? Break it back up so I get this. Do I have a problem with leaving my answer like this?
Yep.
Actually, a couple, don't I? Does this reduce?
No.
Yeah, it does.
It does.
And can I leave that radical sign in the denominator?
No.
No. So 2 problems here. All right? This reduces because this is really square root of x squared times x, right? And what's the square root of x squared?
X.
X. And the x, the lone x is still left inside. Okay? Guess we'll leave that there. All right, now on the bottom, it doesn't simplify, but I can't leave it, the radical sign in the bottom. So what am I going to multiply by?
3.
Square root of 3y over the the square root of 3y. That's correct. And so on top, I'll come back over here, I get x times the square root of 3xy. Do you agree with that? I have an x, a 3, and a y, and we usually go number first and then alphabetical order.
Yeah.
So 3xy. Now on the bottom, what is square root of 3y times square root of 3y? 3y.
Oh, yeah.
Now, these numbers are outside the radical, aren't they? So if they're outside the radical, both of them, and they're a common factor, I can cancel them. But x and 3 and y don't have any common factors. So I can't cancel these. But if they did, then I would cancel them. Okay? So this is my final answer. Okay? Just one more real quick. Something very simple. 1 over cube root of 9. I'm not going to ask you through this. I'm just going to show you something. 9 is really 3 squared, isn't it?
Yeah.
If I want to rationalize a cube root, how many factors do I need?
3.
3. How many do I already have?
2.
2.
So it's times it by
So
3.
all I need to do is multiply by the cube root of 3 over the cube root of 3. Because 3 squared times 3 is 3 cubed,
Probably.
right? And so on top I get 1 times cube root of 3, which is cube root of 3. And on the bottom I get cube root of, I'll take an extra step here. The cube root of 3 cubed. 2 of them here and 1 more there makes 3. 3 cubes. I'm sorry, 3 cubed. And so on top I get cube root of 3, and on the bottom I get 3. Okay? Anybody confused on that? So look at the degree, the index, the root number before you just automatically do it, and ask yourself, how many do I need? And how many do I already have? Now if someone would have said, hey, I'm going to multiply cube root of 9 times cube root of 9, that's not going to work. This isn't going to work because now I only have 2 9s. I'd really need 9 squared in there. And when I got done, I'd have the cube root of 9 squared over 9. And then I'd have to not rationalize, but simplify that. Because 9 is really 3 squared. And I have 3 squared times 3 squared is 3 to the 4th. So it simplifies. So you made your work a lot harder because, yeah, you rationalize, but now you have to simplify. And just to make it quick here, not sure what he said either. I want to shut that off. Three to the 4th. 9 squared is 81, which is 3 to the 4th. And this simplifies to 3 times the cube root of 3 over 9. And now what happens to those? They reduce. So I get cube root of 3 over 3. I got the same answer, but it's going to take a lot more steps. So be careful. Be careful if you rationalize with bigger numbers than you need to. You're setting yourself up for some more confusing reducing to do later. Okay? So be careful on that. All right. We're going to do these. Oh, I forgot also. We're going to have time tomorrow also. We're going to spend a little more time practicing what we did yesterday. So I want you to do 2 through 28, that's 14 problems. You have 17 on today's lesson. And you're going to have tomorrow to work on them also. So I'm not expecting you to run home and get them all done tonight. And then we'll spend some more time answering questions and going through some things tomorrow, okay? So, this is reviewing what we worked on yesterday in lesson 7.1, and this goes along with what we just talked about today in our notes. Okay?